Welcome to a new test and teardown video. This time I'm going to play a little bit with the Escort 3402A Dual Display Multimeter. And I believe this one is from about 2008. Well, it has to be older than 2008. So I'll get back to that once we get inside, and let's see if I can find any information on any ICs or something like that, right? Because in 2008, Agilent acquired the company Escort, and they just rebranded this unit. They simply just changed the name and the front, and this one became Agilent U3402A, and it is exactly the same meter, only the name has been changed. And then in 2014, when Agilent changed name to Keysight, they simply just added a Keysight sticker here instead, or another name on it here. So now it's just a Keysight unit, but it is exactly the same unit, both inside and outside and everything else, right? But the only thing that I can see is a difference. That is this Cal sticker. And on this unit, on the Escort unit, this Cal sticker actually hides a tiny little hole where you're supposed to stick a paper clip or something like that to activate a little switch. And once you do that, you're now in calibration mode. And so don't do that unless you have the calibration instruction and you are ready to do the calibration and all that kind of stuff. I think there is probably something where it will clear the current settings in that particular setting you are in right now. So if you go into Cal, this is the one that you will calibrate. And of course, if you don't do that, you have destroyed that range you are in right now. So, but I'm not super sure about that. I found this how to calibrate on EEV blog. Other than that, I found an eBay listing of one Escort 3146A, and look at that picture. It shows that this type of plastic here around the switches is this funny old type of plastic that turns yellow when it sees sunlight or just getting old and something like that. But this unit I got here is brand new. We actually just packed it out a box, so it was completely unused in a box. So yeah, that's quite interesting. We can also look at the shortly on the overview from their sales sheet, and it says a little bit about how many digits. It's they call it 5.5 digit, but it is actually just 120,000 count. So I wouldn't call it a true 5.5 digit, but that is just what they do, kind of. What we can do is we can play a little bit with it right now. We have, what have we? We have 11.23. What have we? Let's see what we have. This is 11.2344, right? This is our input voltage. And so we should have seen the last two read out as 4.4. So it is a tiny little bit low. Well, that is, I mean, very close to okay, isn't it? Yes, about the Agilent one, when they turned this into an Agilent, they removed this hole for calibration, and the Agilent ones, you can only calibrate them using the serial port on the back, and it says that in the manual for the Agilent ones that this serial port here is only for calibration, and for this one it just says RS232. As you can see, this unit is brand new. So what is this dual display? You can go into the second function and you can, for example, say current. So that means now it's measuring both voltage and current at the same time. But as you can hear, what it's actually doing, can you hear it? Clickety, 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 and it's just switching back and forward. And of course, if you do this all day long, it's probably going to eat your relays, right? And you'll see the update speed is insanely slow. So I think you do that second or shift off, right? So now you're back, and now you have a good, let's see how fast it is actually. We can go here. You see? So this is the update speed. So that is quite nice. About the 12. Yeah, let me go down here. Then you can see it's doing this. So this is, see? Because the 12,000. So if I go under 12,000, what is now going to happen? Here. No. So there's a little bit of hysteresis before it changes ranges. Yes, here we go. Thank you very much. And there you have it, one extra digit. So of course I can crank up the, oops, see, and that happened exactly at the 12,000 count. So you need to be exactly under that right there. Then you can read your voltage, right? And then click. Let's have a little look inside. Mains transformer is really big. I mean, it's using 7 watts. And this is what you get. I mean, this one is a, what, 50, 60, 70 watts. Quite beefy, but I think it's actually to make it weigh something. We got a low-speed serial interface that is isolated. Low speed, you see, 4N29 optocouplers and its own little transformer winding that makes the secondary side voltages. And that will be the driver for the optocouplers. We got a 3 voltages, 3 little regulators here. Yeah, that's exactly what we see. And wires are nicely made here. So there's actually a little funny thing. Mains voltage, mains selector, and then wires go through the isolation barrier and then in here without any filters or anything, right? But in here there's the mains switch filter and a little bit more filter components to the chassis. So that will be the capacitors behind the filter to chassis, and then back to the transformer. So that is a little bit interesting. A nice little, oh, that wasn't isolation here for the back side of the main switch. You can imagine if you are poking around here and you can't really see, this is the main switch. So you don't want to touch that. This is of course all the cables to the entire front panel. All the display stuff. There's a little display driver chip like that. And it's very, very modern, super duper up to date. This is how a brand new designed instrument would look like. And I believe this instrument is from 2006. And I base that on the IC date codes. I've been around the different ICs, and the highest one is 06. A little bit of op-amps here and there. Oops, a little Atmel, EEPROM, another flash, fuse for the high current. Oh, this instrument is actually 12 amps. That is a 15 amp fuse. That is a little bit high, I must say. And the current sense for that is also a big beefy one. Relays to do the different amp volts, modes and such. And I believe inside this case we will have the voltage reference nicely isolated. And there's another thing that I really like about this instrument. There is no fan. So that is really nice and quiet. 6-watt muse. Maybe those regulators could have been mounted on the chassis. I think we should just try and power it up again and have a little look with the thermal camera. We can also have a little look here on the back and see how that is designed. It is a very beautiful circuit board design. Super isolation barrier here. I mean, this is crazy. Why would you do this? Because all the windings goes to the same transformer, and really rectifiers also very high isolation. Here's a funny thing. Why do you think this is necessary when you just have long cables going to all the different voltages? Why would you have this little single point here? I mean, this could have been filled out like that and would not have made a difference. I think this is only to make it look sexy. That is what it is. I like the power switch mechanics. This is nice. The push rod is really thick and stable, so you get the feeling this is good. And also all the solderings are like really beautiful, shiny. Not all this lead-free rubbish we see today. Here it is nice and shiny. So let's look a little bit deeper into this. What have we got? So the first thing we should talk about is what was inside the little shielded So we got two different types of relays, voltage divider, op amp. So this is the LF356, and yeah, so this is just an op amp, right? So all those tiny parts here, they're called Max 4611. All those, there are quad analog multiplexers, and we got them all over the place. As you can see here, it's just amazing how many we got of those. So everything that is switched, yes, here we go again, and here we go again. So we got plenty of those all over the place. And that is, of course, instead of relays. They're, of course, not as good as relays, but they're just all over the place, right? For all the different ranges and whatnot. And what else have we got here? We got AD637. That's also just an op amp. Well, that one here, the AD637. That is the thru RMS to DC voltage converter. So that means everything there is in here that is handling all the different AC voltage ranges, and that's all there is to it, really. And here we got that one, if you look real careful, you can probably see this is the Max 6225 BCSA, and that one is a 2.5 volt ultra precise voltage reference. And then for scaling that voltage reference to different other things, we got one of those ultra precision op amp, the OP177G. This is absolutely an amazing op amp, by the way. And that one here, let me see if I can get some light. Yes, here we go. This is a CS5512. That one is a 20-bit digital converter, a serial output converter, so it's not super fast, but it's actually quite good. So that is kind of what we have, right? Yeah, I think this more or less explains all the most important stuff. Yeah, all those transistors, and this connects in here. That's probably the current injector for resistance measurements. We got all sorts of yeah, this is probably a high precision resistor network. Normally you see those white thick film ceramic substrate, but they're quite expensive, and it's I'm a little bit disappointed not to see one of these, but here they kind of made it themselves. This one is probably compatible with all those super high precision resistors. So there you have it. Now we'll go and assemble this one again. Let's try some of the more normal features here. So this is a 4-point resistor measurement, and this one should be more or less very close to this. Is only a few milliohms away from the correct value, so I'm quite happy about that. Let's try to crank up the frequency. So here is AC volts, and let's go back to 1 kilohertz. That should be, of course, extremely easy. So that is what, 1416, and I measure 1417 here, or almost 18. So it's only 2 millivolts away. I mean, no, it's about 20. Okay, this is just nothing really. So let's crank it. So this is 1 kilohertz. Let's crank it up to 10 kilohertz. Okay, still. And there we go for 100 kilohertz, and then it goes a little bit down here, 200 kilohertz, and it goes a little bit down. See, I still have the same amplitude. And what if I do 300? Yep, and it's the same, but 400 kilohertz. And now there's something funny happening here. This one is a loser. That's of course way out of specifications for that one. This one is not supposed to go fast, but anyway. But the Escort actually totally wins when it comes to bandwidth for its AC. 700. Let's just crank it up and see. Well, that is 1 megahertz. Okay, so there you have it. But 1 megahertz. Now it is not working anymore. Okay, so we need to go back to 1 kilohertz. So if this is the frequency range for the AC, so how about we just go and click frequency measurements. So we just start at 1 kilohertz again. Let's crank it up to 10. Yes, of course. Let's crank it up to 100. Yep. And how about we go for 1 megahertz? I should expect that to work, yes. And I kind of like that it goes to megahertz here as well. So that is quite nice. Let's see if we can give it some more. Nope, overload. So that is 1 megahertz, the maximum frequency it can measure, but so far so good. So that is all I wanted to show you guys. I hope you had a little bit of fun about this Escort 3146A. Hope to see you soon again. Bye!